Hello and welcome to the Q&A session for Teaching Primary Science, both Chemistry and Physics editions. My name's Karen. I hope you've enjoyed participating in the course. We've really enjoyed having the conversations and answering the questions that you've been posing and the thoughtful comments that you've been adding to the two online courses. I hope you've got a lot out of them and that you've got some ideas for using back into the classroom with your own classes. We had a couple of questions from the course. So the first one came from Eloise. Now, Eloise asked, does anyone have, or is there a store of common practicals that people use to cover the areas of the science curriculum? Well, there are lots and lots and lots of different places, lots of websites you can go to, schemes of work you can approach that sort of list some of the more common ones. If you go to the STEM website and you click on primary and the resources button, you'll see all of the areas of the national curriculum for England listed there, and you can click into each year group and you will find lots and lots of ideas for practicals that you might want to do, lessons, learning experiences in there. Another great website that you might want to go and have a look at is the Ogden Trust website, where they have broken down areas of the curriculum and listed some different inquiries that you might want to do. They have some really lovely ideas within there. Other places, the Plan resources. If you haven't explored Plan, they were set up as an assessment network, and now they have examples of planning and long-term planning, and within them they have some common practicals that you might want to do. What's quite nice within the Plan resources is they also list some misconceptions that children might come up with and ways to sort of get around them. And this links really nicely to our second question that we had from Emily. So Emily was looking through the physics course, and she was wondering about the part of the curriculum where we have to explain to the children how light travels in a straight line and is reflected from objects, and that's how we see. And she said, well, how do you get around that where the children think that, you know, there's something coming out of their eyes? And Emily, I had absolutely this example in my class. I had some 10-year-olds and we were sort of approaching that on that part of the curriculum. And I got them to draw how they thought we saw something. So I had on the whiteboard a picture of a cat and a picture of a person. And I said on their own individual whiteboards, can you draw how you think you see that cat? And I would say, you know, 99% of the children had little sort of arrows, like lasers coming out of their eye as to how they saw that cat. We had lots of discussion around of it, you know, do you think there's something coming out of your eye? What do we need to be able to see the cat? And we explored that you needed some light source. So what I asked the children to do was to go into the darkest room we had in our school, which happened to be my head teacher's toilet. And we went in there and shut the door, and we took in one of the soft animals that we had, soft toys that we had in the classroom, and asked the children if they could still see it. Now, unfortunately, there was light coming underneath the door, so they could kind of see it. Now, yeah, absolutely, we can see it. So it must be something going around because there's no light. But then I got them to get a data logger, and we saw actually there was a bit of light. So we blocked up the light. We made sure there was nothing, and they couldn't see it. So then that sort of leads them to that understanding that you do need a light source, something that is giving out light to be able to see something. So therefore it can't be something coming from us, because then we wouldn't need light to be able to see. We'd be able to see at all times. And then I guess it's just a lot of conversation around what it is. It's quite tricky for children because they understand reflection, things like mirrors and of shiny objects. You know, you put something shiny and it will bounce the light and we can see that. It's more complicated when it's a doll or a mat or, you know, fur or anything like that, to understand that it is actually reflecting off. And I think it comes to just a lot of conversations. A really good book that we've explored is this one here, which is called Misconceptions in Primary Science by Michael Allen. And actually that misconception you've mentioned there, Emily, is in this book here. And he talks around sort of ideas that you might approach, but there's lots of other things that in there that you might think, oh, do you know what, that's really interesting. I've never had a child say that to me. How can I address that? What sorts of things can I put in place? So those were our two questions. I hope those answers sort of help to lead you to where you might find some resources around those questions. So after exploring these two, the chemistry and physics course, you might want to explore one of the other FutureLearn courses we have. We have 3 biology courses exploring the biology side of the national curriculum. There's the body processes, we have classification and evolution. We've also got a course around the practical elements of the national curriculum. So that's primary science getting started, and that looks at how to set up working scientifically and inquiry types. The other thing that you might be interested in exploring is the STEM learning community. This is a new place on our website where teachers, technicians, teaching assistants, anyone involved in education can join, and it's a place to have conversations, to share events, to ask questions, and find out what's going on in the world of science, STEM. We'd really love to see you there.